The National Electrical Code, or NEC, specifies the number of downstream receptacles that a ground fault circuit interrupter, or GFCI, receptacle can protect. The load side of a GFCI receptacle can protect up to 10 downstream receptacles. This means that if you have a GFCI receptacle installed, you can wire up to 10 additional standard receptacles to its load terminals, and those 10 receptacles will also be protected against ground faults. A ground fault occurs when electricity flows through an unintended path to ground, such as through a person who is touching a live wire and a grounded object. GFCIs are designed to detect these ground faults and quickly cut off the power, preventing serious injury or death. The reason for limiting the number of downstream receptacles is to ensure that the GFCI can effectively detect and interrupt ground faults. Each additional receptacle adds a small amount of leakage current to the circuit. If there are too many receptacles, the cumulative leakage current could interfere with the GFCI's ability to detect a ground fault. The NEC provides specific requirements for GFCI protection in various locations, such as bathrooms, kitchens, and outdoor areas. These requirements are intended to reduce the risk of electrical shock in areas where people are more likely to come into contact with water or other conductive materials. When installing GFCI protection, it is important to follow the NEC guidelines and the manufacturer's instructions. This will ensure that the GFCI is properly installed and will provide the intended level of protection. Here are some additional details about GFCI protection. Firstly, GFCI receptacles are typically installed in place of standard receptacles. They have test and reset buttons on the face of the device. Secondly, when a ground fault is detected, the GFCI will trip, cutting off the power to the circuit. To restore power, you must reset the GFCI by pressing the reset button. Thirdly, GFCI protection can also be provided by a GFCI circuit breaker installed in the electrical panel. These breakers protect the entire circuit, including all receptacles and other devices connected to it. Fourthly, it is important to test GFCI receptacles and circuit breakers regularly to ensure that they are working properly. You can use the test button on the GFCI to simulate a ground fault and verify that the device trips. Fifthly, if a GFCI trips frequently, it may indicate a problem with the wiring or an appliance connected to the circuit. In this case, it is important to investigate the cause of the tripping and correct any problems. Sixthly, GFCIs are not designed to protect against overloads or short circuits. These types of faults are typically handled by circuit breakers or fuses. Seventhly, GFCIs are sensitive to low-level current leakage and can trip because of it. Eighthly, it is also important to note that GFCI protection is not a substitute for proper grounding. Grounding provides a safe path for fault current to flow back to the electrical panel, which helps to prevent electrical shock. Ninthly, when wiring receptacles to a GFCI, ensure the line and load wires are connected to the correct terminals. Connecting them incorrectly will prevent the GFCI from providing downstream protection. Finally, local codes may have additional or more stringent requirements for GFCI protection, so be sure to check with your local electrical inspector. A GFCI monitors the current flowing into a circuit and the current flowing out of a circuit. If there is a difference of more than 5 mA, the GFCI will trip, cutting off the power. This difference indicates that some of the current is leaking to ground. Common causes of ground faults include damaged cords, faulty appliances, and wet conditions. For example, if you are using a power drill and the cord is damaged, the insulation may be worn away, exposing the wires. If you touch the exposed wires while also touching a grounded object, such as a metal pipe, electricity will flow through your body to ground. This can cause a serious electrical shock. A GFCI would detect this ground fault and trip, cutting off the power before you are seriously injured. Another example is if you are using an appliance in a wet area, such as a bathroom or kitchen. If water gets inside the appliance, it can create a path for electricity to flow to ground. This can also cause an electrical shock. A GFCI would detect this ground fault and trip, cutting off the power. GFCIs are an important safety device that can help to prevent electrical shock. They are required in many locations by the NEC, and they should be installed in any area where there is a risk of electrical shock. Ground fault protection is essential for electrical safety. The 5 mA trip threshold is important. Ground fault circuit interrupters have become increasingly common over the years as their effectiveness in preventing electrical shocks has become more widely recognized. The technology behind GFCIs has also improved, making them more reliable and less prone to nuisance tripping. Nuisance tripping refers to the GFCI tripping when there is no actual ground fault, often due to minor fluctuations in the electrical system. While older GFCIs were more susceptible to this issue, modern devices are designed to minimize such occurrences. The NEC is updated every 3 years, and each revision may include changes to the GFCI requirements. It is important to stay up to date with the latest edition of the NEC to ensure that your electrical installations meet the current safety standards. These updates may include clarifications on which areas require GFCI protection, the types of devices that must be protected, and the installation methods that are permitted. The load side of the GFCI is wired to the downstream receptacles. It is important to ensure the wiring connections are correctly made. The line side of the GFCI is wired to the incoming power from the electrical panel. It is also important to ensure the wiring connections are correctly made. The NEC provides detailed instructions on how to properly install GFCIs, and these instructions should be carefully followed. This includes using the correct wiring methods, ensuring proper grounding, and making sure that all connections are tight and secure. In addition to protecting people from electrical shock, GFCIs can also help to prevent electrical fires. Ground faults can cause excessive heat, which can ignite nearby materials. By quickly cutting off the power, GFCIs can prevent these fires from starting. Regular inspection and testing of GFCI devices is critical. Test the devices monthly to ensure they are functioning properly. Use the test button on the GFCI to simulate a ground fault and verify that the device trips. If the GFCI does not trip when the test button is pressed, it should be replaced immediately. Grounding is important for electrical safety. It provides a safe path for fault current to flow back to the electrical panel, which helps to prevent electrical shock. It is important to ensure that all electrical circuits are properly grounded. When dealing with electrical wiring, always disconnect power from the circuit. Use a voltage tester to verify the circuit is energized. If you are not comfortable working with electricity, it is best to hire a qualified electrician. Remember to consult the latest edition of the National Electrical Code and local electrical codes for specific requirements in Indianapolis and your area.